So a researcher wishes to estimate the number of days it takes an automobile dealer to sell a Chevy Aveo. A sample of 50 cars had a mean time on the dealer's lot of 54 days. Assume the population standard deviation to be 6 days. Find the point estimate, or the best point estimate of the population mean, and the 95% confidence interval for the population mean. Alright, so it's asking me for a couple of things, and when it says find the best point estimate, well, if we had multiple samples of 50 cars, we would go look at those variances and standard deviations and see which one's smallest. In this case, how many samples do we have? Well, we only have one sample of size 50, which means we're only going to have one point estimate, which means we're going to have to use that as our best point estimate, because we don't have multiple point estimates to go look at. So we're just going to have one, and that's going to be my x bar. So we got to figure out what it is. What number in here is my x bar? 54. The amount of days it sits on the dealer's lot. 50 is what? Sample size. And 6 is standard deviation. All right. Now, they said for the second part, so this is my best point estimate because it's the only one I've got. And then they said we want to be 95% confident. And they said we're going to call that our confidence level. So I usually just call it my CL. My confidence level is 95. And I'm going to turn it to a decimal, so 0.95, because that's how I'm going to work with it. What I need is I need a Z alpha divided by 2. And they told me up here, let's go back and see where it is, that alpha, or well, confidence level is 1 minus alpha, which also means that alpha equals 1 minus my confidence level. They gave me my confidence level, and I need to find alpha, so we're going to use the 1 minus confidence level to figure out what our alpha is. So let's take that back down. Alpha equals 1 minus 0.95. So we're going to get 0.5. But to find the critical value, we need alpha divided by 2. So alpha divided by 2 is 0.05 divided by 2, which is 0.025. All right, how did we find critical values last couple chapters? We used inverse norm, or you could use your table. So I'm going to move this just so I get some room. Our Z alpha divided by 2 is inverse norm. And what value should we put in there? .025. All right. So let's put that in and see what we get. Does anyone remember where we find inverse normal? Second vars. We got to get to vars. And then we go to inverse normal. My area is 0.025. And I want a z-score, so I'm going to leave a 0 and a 1 in there. That's the value that I want. And we got negative 1.96, because I'm going to round to 2 decimals. Now, when we got critical values before, what were they? Always positive. Now, we may or may not remember, we've had this critical value before. We had a 1.96. It was the positive version. Now I'm getting the negative version, but it's the same number. Why is it the same as when I put in the 0.975? Because it's to the left, and this is a symmetric distribution. So the z-scores are the same on both sides, but they're negative on one side. Because if you're using a standard normal, 0's in the middle. So if I want the positive version, I can put in that value and then just say, oh, okay, well, I've got, the positive version of whatever shows up here. The other thing is that we're going to be adding and subtracting, so we really are using the positive and the negative version anyhow. So this is 1.96, that we're going to use, and you can put the positive or the negative version there. It doesn't really matter. All right. Then I want to build my interval, so let's see if I can get some pieces in here. To build my interval, that means I need the margin of error, which was my z-score, so 1.96, times the given standard deviation, which is 6, divided by the square root of n. So 6 divided by the square root of 50. And let's see what we get for that. One point something, right? 1.66. All right. Now, according to this formula up here, I want to add and subtract that number from my x bar. So my confidence interval becomes 54 minus 1.66 and 54 plus 1.66. So what does that give me? $52.34 and then 55.66, right? Questions on any of that so far? Yeah. Anytime you're looking for a critical value or some kind of z-score. So you're looking for a z value, you need to use 0 and 1. If you're looking for an x value, you use the given mean and standard deviation. Yeah.
How do you do the comma on the calculator?
Now I've built this interval of numbers. What is this interval of numbers supposed to contain? The what? The population mean, right? The mean of the population. So we used our sample to try to contain our population mean. How confident are we that we contained it? 95% confident that we contained what's going on in the population. Now, that also means we're 5% unconfident that we didn't contain it, but we're at least 95% confident that it is in there. So that's what I want you to tell me. We're going to have a sentence every time. They usually all start pretty much the same. And we say, we are 95% confident that the population mean is between 52.34 and 55.66 days. Oh, I forgot. We're talking about cars. So the mean amount of days that the car sits on the dealer's lot is between 52.34 and 55.66 days. Questions on that? So while we don't know exactly what the population is doing, the exact number, we are able to contain it. We're able to give a pretty good estimate of, well, it's somewhere in between here based on the sample. And like I said, there is a chance that it might not be in there, but we're pretty much 95% confident. Help us with that. So, a survey of 30 adults found that the mean age of a person's primary vehicle is 5.6 years. Assume the standard deviation of the population is 0.8 years. Find the best point estimate of the population mean and the 99% confidence interval of the population mean. All right, so what can we identify in there? N is 30. The mean, and which mean? the mean of my sample, right?
Yes.
Is 5.6, so that's X bar. And what else can we identify?
The standard deviation.
Standard deviation, so 0.8. And we can identify our confidence level. We want to be 0.99% confident. Well, 99% confident. All right. What's the best point estimate? The mean. It's the only one I've got, so it's my best point estimate. Then, I need alpha if I'm actually I don't need alpha. I forgot we're going to use technology. This is all I need. So, I'm going to go to a new favorite spot in the calculator. We're going to spend a lot of time here now. We're going to go back to stats, but we're going to go over to this testing area. And we're going to go down to the one that says z-interval, because we're building confidence intervals for our standard normal distribution. And we're going to go inside and it's going to say, okay, do you have data or do you have statistics? If you have an X bar, a mean, and a standard deviation, you have statistics. They've summarized it, so highlight the statistic. And then go down and it's going to ask you for each piece of your data. So we had a standard deviation of 0.8. X bar was 5.6. Our sample size was 30. And our C level, which is our confidence level, we want to be 0.99% confident. Everybody find this page? So go to stats and go over to the testing area. And you want to go down, it's number 7 on mine. It says z-interval. And then you want to make sure you highlight stats by hitting enter, and then you'll enter in each piece. And when I hit calculate, it's going to give me my interval. So that tells me that I'm in between 5.22 and 5.98 years for this. So let's take our confidence interval back. We have 5.22 and 5.98. And this is from I'll put some stats. So we went to stats, test, and a z-interval to get this interval. Did everyone get it to work? Pretty much what we want to do every time. We are 99% confident in this case. That this time we're looking at the mean age of a car. Is between 5.22 and 5.98 years old. So we're 99% confident that the mean age of a person's car for the population is somewhere between 5.22 and 5.98 years old.